So here is the assignment for today. One of which is you're going to look at the simulation, and what you're going to do is you will pull up this page. You can read this if you want to, but we're going to click begin. So what this is an ice rink, and this ice rink is a frictionless surface, no thermal energy whatsoever. So what we're going to do is you guys are going to record all of the numbers that you need, but down here at the bottom, you can adjust either the spring constant, you can make it more. I'm going to increase mine by 8 to that, and you can change the mass, but you need to record that. Otherwise, it's going to be very difficult for me to know whether you have done this correct. Then what you're going to do is you're going to hit set Trevor. When you do that, you're going to be able to pull, like you can see, this is Trevor, and he's attached to a spring. And so basically they're going to pull the spring back. Right now, he's not going to go anywhere because the spring is at the equilibrium position. But if you pull him back a meter, that's going to build up some elastic energy. If you pull him back 2 meters, that's going to build up even more elastic energy. So what you're going to do is this. You're going to pull back. Boom, like that. And then you're going to fire Trevor. And then you'll see that when he approaches the red blue line, you can hit stop time, start time, stop time. And then that's approximately the time that he had. Now notice this is traveling 18 meters. Now, one thing that I think is important, oh, there's Baby Yoda. Let me pull this up real quick. Equation list. When you are moving on a frictionless surface, it'd be just like the bowling ball rolling across our classroom floor. Therefore, I want to talk about the type of motion. Well, the type of motion that would describe it would be constant velocity because it's not unbalanced. It'd be totally balanced forces. So therefore, you can use this equation here to help you think about the velocity and the time, the relationship between the velocity and time. You know that distance between the blue lines is 18 meters. So you know delta x. And then you should be able to figure out the velocity given energy transfer. So therefore, you should be able to predict the time. So what I'm going to ask you to do on this lab is I want you to first predict the velocity that he would be traveling across here. Then I want you to predict the time. And then you will see if you are correct or incorrect.